All right. 1.13b talks about equivalent ratios and proportions. We know what a ratio is already. We're going to find out about proportions a little later in today's lesson. But there's a little activity up there for you. You're making a comparison as an introduction, as a warm-up. The sentence there, you get to fill in the blank. Painter is to brush as bowler is to... Consensus is we're going to go with ball there. Ball, okay. Teacher is to classroom as mechanic is to... I'm going to say that a mechanic, so a teacher works in a classroom, the mechanic works in a shop. The teacher is to classroom as mechanic is to shop. If you would like to use the word garage instead of shop, I'm okay with that.
Yes, thank you.
The next one is written in ratio form. Letter is to alphabet as finger is to...
Finger.
We're going to go with hand. All right, now taking our knowledge that we just learned and converting it to numbers, again in ratio form. Notice when you see that colon, I say is to. 1 is to 2, as 2 is to... 4, thank you very much. Then 4 is to 12, as 5 is to...
7,
15, 13,
10, 1. 1.
So a little bit of discrepancy here, which is okay. That's what we're going to learn today. But 4 is to 12 as 5 is to 15. So you have to look at the relationship between each term in the first ratio. So the first ratio there, pay attention guys, is 4 to 12. The relationship between them is that 12 is 4 times 3. So then the number that's going to be in a equivalent ratio with 5, we have to times 5 by 3 to get 15. That makes the relationship between those two numbers the same. That's the key, right? A ratio is a comparison or a relationship between two numbers.
Is there ever possible?
Good job. So your little note there, equivalent ratios are ratios that make the same comparison. They make the same comparison. So that 4 to 12 that we had and 5 to 15, they're the exact same comparison. I had to times by 3, therefore here I have to times by 3. So for instance, if you were comparing students to pencils and you said, oh, the ratio is 4 to 12, and someone else said, no, the ratio is 5 to 15, you'd be saying the exact same thing. Okay? Does not matter how many students there are in the room. Maybe there are 20 students in the room. One of you reduced your answer to 4 to 12, and the other one reduced it to 5 to 15. You had the exact same count of students and pencils. Okay? Equivalent ratios. To find an equivalent ratio, all we need to do, and this is one of your notes, is multiply or divide both terms by the same whole number. All we have to do is multiply or divide both terms by the same whole number. We have a couple of examples down there. In example A, we have 3 to 4. We're comparing 3 to 4. Now we want to come up with an equivalent ratio. Well, one of the ways we can do that is by multiplying each term by the same number. In order to see this easily, I'm going to convert from ratio form into fraction form. And then we can see that as long as I multiply the top and the bottom by the same whole number, in this case I'm just choosing 2, I could choose any whole number, I could choose 3, 4, 5, 6, 7, 8, 9, 10, doesn't matter. But now I can say that 3 over 4 is the same as 6 over 8. And then we can rewrite that in ratio form, 6 to 8. So 6 to 8 is just one example of an equivalent ratio for 3 to 4. There are an infinite number of equivalent ratios. Okay? B is another quick example. We're given 18 to 12 as our ratio. This time we're going to show division. So we can create an equivalent ratio by dividing both terms by the same value. So I'm first converting into fraction form so that you can see what's happening here. You don't need to do this. It just makes it easier to see. Now, as long as I divide top and bottom by the same number, I'll get an equivalent ratio.
6.
Sure, 6. Good choice. Okay? Which gives us 18 divided by 6 is 3. 12 divided by 6 is 2. Convert that back into ratio form. So an equivalent ratio for 18 to 12 is 3 to 2. So now this could have been one of the things in our warm-up. We could have said 18 to 12, 18 is to 12 as 3 is to blank. And you'd have to figure out that that's 2 by dividing both numbers by the same whole number, in this case 6. In the next example, we're asked to find out if the ratios are equivalent. What do you think your strategy will be for this, to find out?
We just did this one.
We just did this one, yeah, so that's easy. But what would be your strategy if you needed to find out if 12 is to 8 as 3 is to 2?
Find a common, like what they give supposed to be divisible by.
Yeah, that's one way. Another, so I think this is what you're getting at. We want to see if we can write them in the same way, right? We want to see if we can write them with the exact same terms. If we can write 12 is to 8 in the same way as 3 to 2, then we've got that they're equivalent. So let's take this 12 to 8 and we'll put it in fraction form. And then we'll reduce it. And when we reduce this, both terms are divisible by 4. That's going to give us 3 over 2. And then let's look at 3 to 2. And that one in fraction form is 3 over 2. So since they're the exact same value, exact same ratio, and we can see that, then we can say, yep, equivalent. Example B is a bit trickier. We have 3 to 5 and 50 to 75. Now you'll notice that in example A, we took the bigger numbers, the ratio with the bigger numbers, and we divided each term to make it smaller. We're going to do the opposite here. We're going to see if we can represent 3 over 5. What is that if we represent it over 75? Because this ratio is going to be 50 over 75 in fraction form. But what happens to this guy? Well, in order to get a denominator of 75, what do we have to multiply by?
10.
It's okay, it's 15.
7.
And if we do that to the bottom, we have to do the same thing to the top. So we end up with 45 over 75. Are they equal?
No.
No. So we say not equivalent. At the bottom, you have a little bit of space for a little note here. We're going to write a statement in which the two ratios are equivalent is called a proportion. Okay? So, for example, we had here 12 to 8 and 3 to 2. We determined that they were equivalent. So, we could say 12 over 8 equals 3 over 2. And because this statement is true, it's a statement in which the two ratios, one here, are equivalent, then this is a proportion. Okay, it needs both parts to be called a proportion. It needs two ratios, and the ratios have to be equal. Another way to write this, 12 to 8 equals 3 to 2. Okay, fraction form and ratio form. We could also write it using our words. We could say 12 is to 8 as 3 is to 2. And there you have what a proportion is. All right, example 3. We're going to be solving a problem using proportions. So we have in China, in 1974, archaeologists uncovered a life-sized army made of pottery. Pretty crazy. Near the burial site of an ancient emperor. The soldiers were arranged in rows, forming a giant rectangle. So you can imagine looking at it from above. They dug it out, and there's just a huge area covered in soldiers made of pottery, perfectly lined up. Rows.
Like standing up.
And
Okay,
each one
standing
was
up.
actually different.
Yeah?
Yeah.
Nice.
And
We're told each one was
lines
actually
in there
different.
like that?
No,
those are not.
No. Okay, so to estimate the total number of soldiers in the army, do you think the archaeologists dug up the whole thing in order to get an estimate?
Yes.
No. Okay, they probably eventually did, but they excavated a 10-meter strip of the 200-meter long rectangle. So they figured out that the army was 200 meters long,
How did they know that?
and they excavated 10 meters of that 200 meters. Told that in that 10-meter strip that was excavated, they found 270 soldiers. So we're going to develop a proportion that's going to allow us to estimate how many soldiers were in the entire army in the whole 200-meter long rectangle. So I didn't leave any room for it, but above example 3 you have the margin there. Let's use that space to draw a little picture of what's happening here in order to wrap our heads around the situation and help us to develop our proportion. We've got a rectangle. We don't know how wide it is. Really, it doesn't matter. But we know that from here to here is 200 meters. And we're told that they're going to excavate just a 10-meter strip. So this, from here to here, is 10 meters. So that's what's happening. And in here is all the soldiers are in that blue box. We're using that 10-meter strip to estimate the total number of soldiers in the whole 200-meter length army. Okay? What do you think we should do?
Times it by
200 divided by 10. No. Wrong.
So what you're doing is you found a ratio to say how much did they dig up. Well, there's 200 meters and they dug up 10 meters of it. So 200 divided by 10 is 20. The ratio of what they dug up is of the real is 1/20th. So that means the number of soldiers that they found in here, what are we going to have to do to that number?
Divide that by 20.
No.
it by 20.
We're going to have to
Times it by-
multiply it
Yeah.
by 20 in order to get the total number of soldiers, an estimate. Okay, that sounds great. We're going to do it algebraically. So again, our strategy for solving this is going to be setting up a proportion using two ratios. One of the ratios we will have complete, and one will be missing some information. The ratio, which involves what we're trying to find out, is the total number of soldiers over the length of the rectangle. Length of rectangle. Now you look at that ratio and you say, okay, I don't know the total number of soldiers. That's what I'm trying to find out. I do know the length of the rectangle. Now our next ratio is going to help us create a proportion, because the second ratio is going to be equivalent to the first ratio. This is, or at least an estimate of the first ratio. This is the number of soldiers found. So this is the number that they actually excavated over the number of meters excavated. So we'll say the length of excavation. And we know both of those numbers as well. So this is going to be turned into an algebra statement as long as we first introduce a variable. We're going to use the variable x, the most commonly used variable in algebra, and we are going to let x represent the total number of soldiers. And that makes sense to let it do that. That's what we're trying to find out. That's the only part of this proportion that we don't already know. So, in algebra, we're just going to take this proportion down, but we're going to replace all of the information that we know, and we're going to use x for the total number of soldiers. So we've got x over the length of the whole rectangle which is 200 meters. And that ratio is equivalent to the number of soldiers they found, which we're told they found 270 soldiers in the 10-meter strip that they excavated. So there we have our proportion set up. You can see one of the ratios already has all the information needed. And now we're going to use a couple of different strategies in order to solve this problem. Your notebook page there is already divided into 3 sections. We are going to use each of those for a different method. So over in the left box, you can write M1, which is going to be use equiv for equivalent ratios. Use equivalent ratios. So we're told, if we just take our sentence down here, we've got x over 200 equals 270 over 10. Now, what we can do to find out what x is we can get the same denominator for each of these. If we could write this second ratio as a fraction over 200, but keep an equivalent ratio, then the number left in the numerator would actually be equivalent to x. So what I'm asking is, how can we represent the denominator as 200? What would we have to do to 10 to turn it into 200? Well, we had to multiply by 20. Now the rule is, if we do something to the denominator, in order to keep it equivalent, we need to do the same thing to the numerator. So I'm going to multiply each of those by 20, which is going to give us something over 200. And if you can't do this in your head, you break out your calculator, you end up getting 5,400. Now, we have x over 200 is equal to 5,400 over 200. Well, that must mean that x equals 5,400. And if we were going to finish our problem here, we could write a sentence with our solution. The total number of soldiers is estimated to be 5,400. So that was solving using a strategy called equivalent ratios, where we basically took the 2 ratios that we knew, created a proportion by setting them equal to each other, equivalent ratios, and then figured out, okay, what do we have to do to get the same denominator? And that reduces us to x equals 5,400. Method number 2, we're just going to tell what we're going to do. We're going to multiply by 200. And that sounds not really a great description of what we're doing, but this would be my favorite strategy. Basically, if you have x over 200 and you have 270 over 10, you've got a proportion here. And I think of this algebraically. I want to solve for x, which means I need to get x by itself. Right now, x is being divided by 200. In order to undo that and get x by itself, I need to multiply by 200. If I take a number and I multiply it by 200 and I divide it by 200, I'm just going to get that number again. So I'm going to take the left side of this proportion and multiply it by 200. Now this equal sign means that anything I do to the left side, I also have to do to the right side. So I'm going to take that side and multiply it by 200 as well. Well, over here on the left, this reduces to x, right? X divided by 200 and then times 200, you're just going to get x back out again. Or you could think of it as, okay, now I have 200 in the numerator and 200 in the denominator. They both cancel out to 1. X over 1 is x. On this side, we can use our calculator. We can do it a couple different ways. You could do 270 divided by 10 times 200, or 27 times 200. Or you could do 270 times 200 divided by 10. Any way you do it, you're going to end up with 54,000 over 10, and then that's going to reduce to an approximation of 5,400 clay soldiers. Again, that would probably be my go-to method. The third method, though, is also very important and helpful in lots of situations. It's called using the cross product rule. So some of you have asked, okay, is this kind of like using cross products? And, well, here it is for you. Okay? we've got the cross product. We're going to just take down our exact same proportion that we've been using the whole time. We've got x over 200 equal to 270 over 10. And the cross product rule really works kind of based on this algebraic strategy that we used. But basically all you have to do is take the numerator from one of your ratios and multiply it by the denominator of your other ratio, and then take the numerator of the second ratio and multiply it by the denominator of your first ratio. Then you're going to set those two products equal to each other and then solve for x. So here we have x times 10. On the left side, that gives us 10x. We're going to set it equal to 200 times 270. So as we work that through, we've got 10x is equal to 54,000. Sorry. Yeah, 54,000. And then we're going to divide both sides by 10, leaving us with x equals 5,400. Again, giving us the same estimate that if in the 10-meter strip that they excavated they found 270 soldiers, then it's estimated that there will be about 5,400 in the whole army. We would write a sentence to finish that off as well. Okay, example 4 gives us the opportunity to use a couple of these strategies that we used in example 3 in order to find the unknown term. So in A, you've got 30 is to 24. 30 to 24 is equal to x to 8. The unknown value, of course, is x. Now, we're going to set this up as a proportion using fractions in order to use the second method there, which is my personal favorite, to just solve for x by undoing the operation that's attached to x. So on this side we have 30 over 24. On this side we have x over 8. Now because x is in the top, x is in the numerator, this strategy is really easy to use. Basically all I need to do, x is being divided by 8, I'm going to undo that by multiplying it by 8. If I do it to one side, I have to do it to the other side. So here we're going to have, on the right side, it's easy, we're just going to have x. And then on the left side, we have 30 times 8 divided by 24. Well, 30 times 8 is 240. Oops. And that's going to remain over 24. And then hopefully you can see that 240 divided by 24 is going to leave you with 10. So x equals 10. In example B, we're going to use the cross product rule to get a little practice with that. So B says 4 over 1.5 is equal to 10 over n. So this one was already given to us in fraction form, so we don't need to play around with that at all. But what we're going to do is multiply the numerator of our first ratio times the denominator of our second ratio, which gives us 4n. And on the right side, we're going to end up with the denominator of our first ratio times the numerator of our second ratio. So we've got 10 times 1.5, which is 15. And now I just solve for n. Right here, n is being multiplied by 4, so I can divide both sides by 4. These guys are going to cancel out. Leaving me with n equals 15 over 4. And we could also reduce that, or not reduce, but we could convert that into a decimal and say n equals 3.75. Your problems, your practice problems, are listed there at the bottom of page 13. For 1.13a, they come from page 312, and that's numbers 1, 3 through 6, and 10. And then for 1.13b, which is what we just completed, you have page 319, number 1 through 29, question 32, and question 33. Please come to class with questions if you have any.